function right here. Let's say it was x squared plus 9. Yeah? Hey, Nina, good morning. Chris is here too. George is here too. Good morning, gentlemen and ladies. Hope everybody's doing well. So listen, we had a question. Angela had a question about the last question on your test, where it was talking about finding integer coefficients for a polynomial function that had roots of like I and negative I, right? And so I was trying to figure out how to explain this without just giving you the answer or showing it. So what I was going to do is I was going to kind of work it backwards. So like if we had this function right here and we went to go find the intercepts, this is what we'd get, right? So we'd have, take the square root of negative 9, you get 3i, and you get negative 3i. Those are your x-intercepts. Those are your roots. So this is a polynomial function with real coefficients. So the coefficient would be 1, right? So it'd be 1x squared plus 9. So when it says real coefficients, that's what it's talking about. Or integer coefficients, it just means these. So things that aren't integers would be things like fractions or irrational numbers like the square root of 7. Those are not integers. So integers are positive and negative whole numbers. So 0, 1, 2, 3, 4, 7, 11, you know, you got it, right? So Angela, what it's asking you to do is to figure out what equation, what polynomial equation would have these solutions. So for example, let's say instead of these two solutions, let's say it was 4i and, oh, hey, Jesus, how are you doing? Let's say it was 4i, hold on, let me come up with I'm going to try to come up with a little bit of a trickier one, but I don't want to. Let's see, 16. Yeah, so, well, let's just say, we had this right here. We'll keep it simple at first. So let's say the same exact question, right? So let's see what that question was. So it says, find a polynomial function that has leading coefficient of 1. Morning, Omar. And integer coefficients that satisfy the following conditions. So the function has a degree of 2 and zeros of I and negative I. So we did one. We did an example where we had a leading coefficient of 1, degree of 2, but the solutions were 3i and negative 3i instead of plus and minus I. Right? So what if instead, what if it said this? Here, I got an idea now. I'm starting to wake up. I've been awake since like early this morning, but just one of those days, like the opposite of yesterday. Yesterday I was like all full of energy and ready to go, and today, not so much. So let's say we had to find a polynomial with a leading coefficient of 2. And let's say a degree of, let's keep it simple, of 2. And let's say it had solutions or roots that were plus or minus 4i. So we've got 4i and we've got negative 4i. Yeah. And so same question, different parameters, right? So it's same style question. Are you good with this? You guys following me? Do you see how this is related to the, like it's kind of a different example of the same thing on the quiz? All right. I'll take silence as consent in this case. As yes, I got it. All right, so there we go. I don't know which is better. So anyway, we need a degree of 2. So that means it's going to be an x squared. It could have an x, but it might not. We don't know. But the leading coefficient is definitely 2, right? And so here's the thing. Like if these are our solutions, then what we end up with is x equals 4i, and we have x equals negative 4i, right? And so we have to figure out what kind of equation could give us that. And so one thing you can do is you could actually square both sides if you wanted. Oh, well, this is a degree of 2, so. Well, either way, you could square both sides if you wanted. So you could go x squared equals, so that's going to be a negative 16 Are you guys good with that? You guys see why it's going to be a negative 16? Because I squared is negative 1, 4 squared is 16. So this would be x squared plus 16 equals 0. So you know how when you're finding x-intercepts, you take your polynomial function, you factor it, and then you take each factor and you set it equal to 0? Well, so this would be one of the factors. Yeah. X squared plus 16. And so this one, actually, if you were to solve this, there's actually two answers, and the other one's negative. Do you see? So if you had x squared equals negative 16, and you took the square root, you get plus and minus 4i. So we've already got this one covered. Do you see? So here's what we got so far. X squared plus 16. That's our function, right? The problem with this answer is it says the leading coefficient is going to be 2. So I have to adjust this some way. If I make this just a 2, if I had 2x squared plus 16, and I solve that, I don't get 4. I get 2 root 2. So what I need to do is I really need to do that. So it's going to be 2x squared plus 32. And that would be my answer for this question we just made up. How we doing? How we doing, young people? Good, bad, what? You can just leave a message in the chat if you like, or you can just say, hey, I'm good, or no, I'm not good. With this example. So that was for this one. Second one's a lot trickier. 1 plus or minus the square root of I. So I'll give you a clue about the second one, B. For B, I would, let's see. How do I want to say this? So you know how sometimes you can't solve by factoring? You have to use a quadratic formula. Well, if it's degree 2, you're going to use a quadratic formula. And so what I would do is, well, here's what you got. I'll just give you a clue. 1 plus I, and you have 1 minus I, right? So you know how you have b squared minus, or, plus. Let's use the plus. Negative b plus or minus square. Let's see, 4ac over 2a. You need these to be equal, right? And you also have to remember that this is written, and this is a complex number, so it's written like this, right? These a's and b's aren't the same as those a's and b's, right? It's just, numbers. But here's the deal. Whoa. That was supposed to be a 2, George. Do you see? So you need to figure out how can this equal 1 plus I. So here's the deal. 1 second, Angela. I see your question. Let me finish my thought here. So you see these two things have to be equal. And A is the same as A, and this B has to be the same as that B, and this has to equal I. So you could set up a system of equations maybe. Maybe you can just kind of figure it out. I don't know. It's up to you. Hey, good morning, Ruben. How are you doing today?
Good.
I'm all right. I'm okay. I think it's allergies are killing me. I'm feeling really run down today, and I slept well. I don't know what's going on. So Angela says, how would you know when to do the square root of a negative or moving it to the other side? Well, you don't know. So that's what's tricky about a lot of things in math, especially when they're like paper 4 problems, or you have to do this a lot in calculus too. You won't be sure of what the best step. Sorry, I'm up the microphone. You won't be sure what the best step is, or you won't be sure of what the best approach is. You kind of have to try something and see if it works. And if it does, then you're good. And if not, you kind of have to think about why it didn't and adjust your method on the way. So you have to take a little bit of a risk and a leap of faith, and you have to be confident. This is where I struggle. When I'm not sure of how to best approach a problem, what I end up doing is I end up second guessing myself too much. And so what you've got to do, when I'm able to keep this in my mind, the idea that if this doesn't work, I can figure it out from here. If I can keep that in my mind, I'm good. But if I start getting frustrated and say, oh, that didn't work, screw this, I can't get it, then I'm not very successful. So when I was a student, that's what I really had to learn how to do. I really had to learn how to just be patient and confident and realize that sometimes you're not sure what the path is, but you just try something and see if it works. And if it does, you're great. And if not, it's not a loss because you've gained information. You figured out what didn't work. And sometimes you figure out what works by figuring out what doesn't work first. Yeah, that's kind of what parents do with oldest children. And I'm an oldest child, so they made all the mistakes on me. All the stuff that didn't work, they figured out with me. Yeah. All right. Let's see. Let's see here. What other questions do you guys have that we can go over? Because maybe we can do another one of these, but you got to give me a second because I can't make these problems up off of the top of my head. I need to think about it for a second. So let me see if I can get one. And then let's see if we can figure that out. Let's see. No, I don't want. Okay. I think this will work. Nope. All right. So do you guys can just let me know in the chat if you don't think it'd be a good idea to practice one of, like, what I'd like to do right now, I think would help you is make up an example, an alternate question for number 10, and then kind of run you through it. If you don't want to do that, we don't have to, but if you want to do it, just say, just in the chat, say, yes, let's do that. So yes means let's do that, and no means let's move on. Because I'm trying to come up with a problem right now. And yeah.
Could we go over the few last ones on the test, or did you already do those?
Which ones?
Like the last question.
Like number 10 right here?
No. It's the one that's like x to the power of 5 plus 6x to the power of 3 minus 10x equals 0. And then it asks to find the solution.
This one. Number 5.
Yeah,
got it. Okay, so like on the Google quiz, they shuffle the order. So so it gets kind of mixed up. Yeah, we can do that. We can absolutely do that. Let's see. So let's see. And round to 2 decimal places. Well, let's see. I don't want to just do the problem for you. Let me think here. So the thing I notice, like right off the bat, is that you can take an x out, right? And then when you do, this is going to be, are you guys, yeah, you're seeing my screen. So when you do, this is going to be, let me see, this is going to be x to the 4th right here. This is going to be x squared. So this is a trinomial that's going to be in quadratic form. Do you see what I mean? So I can come up with an example of this, no problem. So let's do this right here. All right, so I got an example. Here, let me turn on my document camera, okay? So we're going to find all of the solutions to the 100th place, right? So let's do this equation. Can you guys hear me okay when I'm using the document camera?
Yeah.
Okay, good. All right, so let's try this one right here. I'm sorry, I didn't turn on the lights. There we go. That's a little, no, that's not even better. Let's try, maybe. All right, so this one right here. So here's what we're going to do. We're going to find all of the solutions to this, right? And it's factorable. So we can take out, for sure, we can take out an x. Do you see? You can have 3x to the fourth plus 2x squared minus 7 equals 0. Good to go so far? All right, now, if this was a 4 instead of a 2, the whole thing would be factorable, but it's not. So this part right here, we're going to have to use U-Substitution. We're going to have to substitute. So here's what we got. We got x equals 0. We have 3x to the fourth plus 2x squared minus 7 equals 0. So first step, factor. Second step, set each factor as an equation equal to 0, and then solve them both. This one's already solved, so we're done there. This one's not solved, so we have to. But it's not quadratic. So we can't use the quadratic formula, and we can't factor it anymore. So with the tools you guys have at your disposal right now, the only thing that you can do is you can do U-Substitution. You can say, well, use x squared. So because we can't figure out what this is, but if we say that if we had something like this right here, we can solve that. You see? If u is x squared, then it's true that u squared would be x to the fourth. Do you see? So we're just doing that substitution. And then once we figure out what u is, we're going to come back and substitute our answer for u into this, and then just take the square root. Yeah? All right, so u is -2 plus or minus the square root of 4 minus 4 times -21 over 6. If I make a mistake, say, hey, wait a minute. I don't think I made a mistake, though. I think that's going to be, let's see, I think this is good. So that's 84, which makes 88. So u equals -2 plus or minus the square root of 88 over 6. All right. So using our handy-dandy calculator here, I'll put it on the document camera so you can see. That way if I make a mistake, you can tell me. Oops, I did make a mistake. -2 plus square root of 88, and then divide that by 6. Here's what we got. 1.2. That's interesting. That's cool, right? 1, 2, 3. That's the positive, and then we also have a negative, right? So -2 minus the square root of 88, and then divide that by 6. -1. Oh, so this one we have to round. Remember, we have to round to hundredths place, so we have to look at this one. Oh, yeah, no, I did that one right. I just wanted to make sure I rounded this one right. So here, I have to round to hundredths place, so this is going to be 1.90. So there we go. Now, that's what u equals. It's not what x equals. We have an equation for x. And so what we did is we used this to kind of break. We used u to take this equation and break it into something that's smaller that we can deal with. And once we figure out what this smaller part is, we can then plug that back in. So since u equals x squared, like this is u, which also means it's x squared, right? So all we got to do is take the square root of both sides. These two are real, and they're going to be two imaginary here. So second square root of 1.23 is, we have one that's a plus 1.11 and one that's going to be a minus 1.11, right? Because square roots have, positive and negative answers. And then this one, it's going to be imaginary. So I can't type in the negative, because if I type in the negative, here's what's going to happen. If I type in -1.9, it's going to give me a domain error because it's not real, not a real answer, right? And this calculator doesn't do imaginary. It doesn't do complex numbers, at least. I don't think it does. Maybe there's a setting. But anyway, so you're going to have to do second square root of 1.9, and you're going to have to take care of the imaginary part yourself. So we have 1.38, rounded correctly, right? Times I, and -1.38 times I. So all 5 solutions, there are 5 solutions to this, 5 roots, right? We have 3 that are real, 2 that are imaginary. So he has a multiplicity of 1. So we have x equals 0 with multiplicity of 1. And then we also have 1.11, negative 1.11. We have 1.38i and negative 1.38i. There we go. How's that, Ruben?
Well, it's because I did all of that for the actual test question, and it gave me something completely different.
What do you mean? Oh, it gave you different than what the answer said when it was typed up?
Yeah.
Oh, that's weird. I don't know. Maybe I made a mistake on it, but I don't think so. It's easy to make mistakes on these. I'll check, okay? I'll double check the answer on that. And then if it's wrong, I'll email you and I'll adjust your score. But I don't think so. But who knows? Hold on. I can check right now. Let me just put it on my other screen. X to the 5th.
Maybe I just did some sign error.
It's super, super easy to make a sign error. So this is number 5, right? 0. Oh, I do remember doing this one. Yeah, I did this one twice. All right. I'll check on that, okay? Well, actually, I can check a little bit of it right now while you guys are here. What other questions do you guys have that you guys would like to go over? Angela, have I answered your question?
Yes, but I had another question on 1C.
1C. Okay. Hold on. Let me get there. Let me check this real quick. Yeah, Ruben, I am pretty sure. I know for sure, like I just checked right now. I know for sure my real answers are correct, so I'm pretty sure my imaginary answers are correct too. So, Ruben, I think you might have made a sign error on that one, but I'll check. I'll take the time to check more carefully later on. Okay, like after we hang up. So, Angela, you said number 3.
1C.
Oh God, I don't know where I got 3. All right, 1C. All right.
It's about the AND behavior, but I just had a question. Would I distribute everything like the negative 5x to the negative 2x cubed? Like
You
the
can. Yeah, so
and that would make the leading coefficient positive, so then it would be up both ways, right? Or would
that's
it be
right.
like
Because it's a degree of 6. Yeah, that's right. You got it.
Yeah, that was it, yeah. Thank you.
Yeah, you got it. Man, killing it. Yeah. All right. Let's see. What other questions you guys have? None, huh? All right. I'm going to check. Ruben, while we're here, I'm going to go ahead and check the other answer. I'm not going to show you guys, right? But I'm going to go ahead and check my other answer just to make sure I got it right. Let me get my calculator. Let's see here. Anybody else that's here? Dang it. My computer's being like super. Oh, no wonder. My computer's being a little buggy, but it was me. All right. Let's see here. So anybody else that's here, do you guys have any other questions? Yeah, I know. I thought I fixed it, Omar, but maybe I don't know. I'm not sure how. You're right. The answer key was had a mistake. I did fix it, but I don't know if I don't know. Google Classroom, like here, I'll show you what it does. Let me see. Nope. Hold on. Well, regardless, I think what it might end up doing is it might end up locking it so I can't go back and edit it. Either, yeah. So you're right. You're right, Omar. It is up both ways. And yeah, I don't know. I don't know why I did that. So it should hopefully, like if you do it right now, it'll work. In fact, I'll try that. I'll do it. I'll do the quiz myself also, and see if that works. All right, and then so I'm just checking that one question, Ruben. Yeah, that's right. So Ruben, the answer key for that question, number 5, I think it was, it is correct. Yeah, so we're right on that one. And then since we're here, that's weird. Ah, Yesenia is here too. Hey, good morning, Yesenia. Since we're here, ladies and gentlemen, Omar, I'm going to go ahead and just double check that I did fix that answer. And maybe you took the quiz before I fixed it. I'm not sure. Okay. I'm looking it up. I'm trying to find it right here. So this is number, describe the end behavior of the function. Yep, I got it. Let me check. Because it's definitely up both directions. Yesenia, how are you doing today? Oh, that's weird. Up both directions. Okay. So yeah, it was, okay, so it's fixed now. Maybe I fixed it on a different copy. I'm not sure. Yeah, I don't know. So Omar, it's fixed now. If it doesn't change your grade for you, I'll go back and fix that myself. Good. I'm glad you're doing all right, Yesenia. What other questions you guys have on any of the questions on the test or anything else we've learned? You guys doing okay? Man, maybe now I can go get a real haircut. I was going to shave my head. I just never did. Oh, no. So you guys are feeling okay. You're feeling rock solid. Yeah.
I have another question. So when it says global maxima, it doesn't mean infinity. It just means like the little vertex.
That's right. So for example, here, I'll give you some, let's see. Let me turn on my document camera again. I'll give you some examples, right? So, yeah, that question's kind of tricky. That one question, if you're thinking of the same one I'm thinking of, it's kind of tricky. So global maximum. So let's talk about global max and min. So global minimums and maximums, right? We've got kind of like 2 examples here. So this kind of thing, it doesn't have a global minimum or a global maximum because global max means the absolute highest possible output. And because this one is going up to the left, there's nothing that's, it goes to positive infinity. And on the right, it's going down, so it goes to negative infinity. So there's never a global. You have a local maximum right here, and you have a local min right here, but nothing global, right? So the idea is also that this sketch has an odd degree for sure, right? So if you have an odd degree, you're not going to have a global minimum or a global maximum. If you have an even degree, then you could have something that looks kind of like this, right? Or it could go down. It doesn't matter. This right here, this one doesn't have a global maximum because it's going up both directions. So it's going to positive infinity in both ways, right? But it does have a local max right here, right? And it's got 2 local mins. Got a local minimum right there and a local minimum right there. But this one here is also global because it's the smallest output for that entire sketch. And this is an even degree. that give you the idea, Ruben?
Yeah.
Cool. All right, that's good. Cool, good. That's a good question. That's a good question. What other? I don't know. Oh, I just got an email about second semester grades. Okay.
Mr. Brown,
Yeah.
so would that mean for number 3 we would have to graph all of them to find the global maximum?
No, it's not asking you what it is. Let me see. It's just asking you which will have one. So it's not asking you to find what it is. It's just asking you which of these functions will have a global maximum.
Okay, thank you.
You're welcome. Yeah, that's a tricky question. What's that?
I just realized what I did on number 5.
Yeah, what was that?
I plugged in the wrong value for A.
I hate when I do. It's, algebra's tough because there's so many. Algebra's tough because there's so many things you have to be careful of. And it's so easy to make like little mistakes. And those little mistakes can be a real pain because they add up and cause like massive errors. So, yeah, I understand. I feel your pain. Okay, Omar's got a question. So Omar, those 1.36 and stuff, those are not the solutions for X. That's the solutions for the U-substitution. Do you know what I mean? Let's see. I thought I just did it. Where did I just do it? Let me see what you're saying again. Hold on, let me check. Yeah. So Omar, do you understand what I mean? When you did U-substitution, those are the solutions you found, which is fine, but you have to use those solutions for U to figure out what X is. So on the hold on, let's see. So on the example we just did, let me turn on the. So let me turn on the document camera again. Okay, so like on the example we just did, you know how we solved for U and we got these two answers right here, right? You have to take the square root of those still for the example that you did, because when you do the example, you do get like 1.17, and I forget what the other is, but you have to take the square root of those again. Okay, I see what you mean. Hold on, let me look. Scrolling on the mouse. Right. Okay, yeah, no, that's right. Why did the answer say it was wrong? So you're absolutely right. I got confused. And that's what I did right here. 1.17. See, what number was that? Let me check. I'm looking in the Google quiz. Like, here's our quiz on the Google. Let me see if let me see if I had an incorrect answer. I can't even find the question. That is so weird. It is this one right here. It is x to the 5th plus 6x cubed minus 10x, x to the 5th. I'm not even seeing it in the Google, I know it's there. That's so weird. I must be on crack or something because I can't find it. Oh, there it is. Okay. So let me see. Let me check into this for us, Omar. Let me see what I got for answers. Oh my gosh. Oh, no, that's okay. Okay, that's good. Oh, I see what you mean. Yeah, so I got you. So one for the positive one, it told you were wrong and you were right. Is that what you're saying, Omar? Yeah. Okay. So the others were right. It's just the positive one. I see. Yeah, I don't know why it said that. 1 point maybe. Yeah, I see. So I just typed it in wrong because the positive was right and the imaginaries are correct. I think. Let me double check on the imaginaries. Okay. Yeah. So you're good. Yeah. All right. So we're good. We're good. Okay. Yeah. You're good. Man, see, that's why Omar. That's why you are. Let's see. That's why you are definitely. Definitely. All right. So let's see. What else? Are we doing good? Beyond that, you guys have other questions? I think restaurants open up soon, or maybe they already have. They can work at like 60% capacity or something like that. So things are starting to open back up, which I hope is good. All right. Anything else? I think we're all good then. I mean, hope we're all good. All right. Well, let's see. I think 2 people have turned that quiz in so far. I think that's it, right? We've got, I got two responses so far. We've got probably, let's see. Oh yeah, Ruben and Omar. Cool. That's weird. It says turned in, but it doesn't tell me the grades yet unless I import them. Oh, that's fine. Let's see how I'm gonna see how you guys did. Oh yeah, you guys did good. Both of you did good. Yeah, you guys did all right. All right. Well, Chris, when's your next tattoo? I guess never. All right, ladies and gentlemen. Well, if you guys don't have anything else, we're gonna sign off. If you have other questions, they come up later. You're doing a quiz, whatever you're working on, anything we've done over the summer, actually anything at all, any math question, whatever you have, we can do this again. Yeah, no problems. So yeah, just send me an email if you want to go over any of the things on the test. If you don't necessarily need to meet, then we can just I can maybe just answer in the email or whatever. But if you want to meet and we can go over stuff together, then we can do that too. So just let me know either way. All right, guys. Well, I hope you guys are having a good day. I hope you get a killer lunch because it's almost lunchtime. Although some of you guys just probably woke up, so it's almost breakfast time. Either way, I hope whatever meal you have around midday, like day is defined as when the sun goes up between when the sun goes down. So I hope that whatever meal you have midday is spectacular today. Yeah. All right. Well, it's been real fun, and I hope you guys have a good day. I'll talk to you guys later, okay?